Hi everyone, welcome back. Today we're going to have a look at some AI and ML through the lens of trying to solve a maze. So the base maze we're going to try and solve is as shown, with the entrance at about the top left and the exit at about the middle bottom area. I'm first going to have a look at some intuitive methods of trying to solve the maze. The first method I will call the dead-end elimination algorithm. So here what happens is we have an agent, which is a blue dot traversing through the maze, and when we hit a dead end, we mark it with a red marker and backtrack to try another path. And again, if we hit another dead end, we would then mark that with a red dot and carry on backtracking, marking dead ends when we find them, until we eventually solve the maze. So we're solving the maze by just randomly going through the maze and finding dead ends, marking them, and eventually we should find our way through the maze by elimination, or as the name says, eliminating all the paths that lead to a dead end until we're simply left with the path that leads to the exit. So there's a few trials of that algorithm running here. So with this algorithm, you see that sometimes we go through quite a lot of the maze, but sometimes when we reach junctures, we are lucky enough to randomly pick the correct direction, and so we have less of the maze to traverse through before actually finding the exit. So after a few trials of the base maze, I tried to trick the agent or the algorithm by modifying the maze. In this case, I added an alternative path, a loop, and a block there. So the intention is to see what happens if we mess up a little with the original base maze, and we want to see how the agent actually handles these additional challenges. So in trial 1 here, we see that the agent ends up taking the alternative path, which is much shorter than the original path, so we get a very short run. And in our trial 2, we actually see the agent encounter all our obstacles and see its behavior there. So with the block there, we saw that it just moves around until it finds its way out. And hopefully I'm seeing that we might see some loops. We've looped back. Now we're approaching our loop, going around a couple of times, and we found the exit. So that wasn't too bad. Now here I just add a few more alternative paths to see how this extra disturbance affects the algorithm. And in the couple of trials that we have, we see that yes, we do loop around and back and forth thanks to the loops and alternative paths created, but in the end we do find the exit. We could, of course, theoretically go back and forth through the loops infinitely without finding the exit, but that's quite unlikely. But yeah, it is possible. The second intuitive algorithm I want to look at, I will call the split agent algorithm. So in this algorithm, our agent, which is the blue dot, oh no, I think I made it magenta in these examples, runs through the maze, and each time it comes to a juncture where we need to decide which direction to go, it splits itself into several agents. For instance, if we reach the first juncture where we have to decide to go up, down, or forward, the agent will split itself into 3 agents, one to go up, one to go forward, and one to go down. And as each subsequent agent traverses the maze, when it reaches a juncture, it'll split itself again into separate agents for each possible choice. And by the end, one of these agents will find the exit, and then the algorithm will stop. So essentially, we're just exploring all possible paths, each path being assigned to a particular agent, and then the agent that finds the exit runs back to the start, highlighting the solution path. So again here I introduced alternative paths and the block and loop to see how the algorithm would handle this. In this case, we see that there's multiple splitting at the loop. So the loop is being handled by the part of the algorithm or the agent that splits and moves outside the loop, but there's an agent that splits and continues in the direction of the loop. So that is kind of repetitive there. And alternative paths are used, so there will be an agent that takes the alternative path and finds the shorter route. But the big problem is the block, where there's quite a lot of splitting that happens there, and I ended up stopping the algorithm because that took a lot of processing power and delayed everything. So the block seems to be a very huge problem for this algorithm. Keeping that in mind, when I created the additional paths, so the third maze, I chose to remove the block so we could just see how this algorithm just handles the alternative paths and the loops created. So this is the new maze, and let's see how we handle that. So this is much better, and we have the alternative path being found as the solution. Okay, and that's that for the intuitive portion for solving a maze. Thank you.